Now we are discussing some formulas. Section modulus. Ratio of moment of inertia about the neutral axis to the distance of extreme layer from the neutral axis. The ratio of moment of inertia about the neutral axis to the distance of the extreme layer from neutral axis. Section modulus is nothing but moment of inertia about the neutral axis divided by distance of extreme layer from the neutral axis. So moment of inertia about neutral axis divided by distance of extreme layer from the neutral axis. We know that maximum bending stress occurs at outermost layer. Maximum stress occurs at outermost layer. Let y max equal to distance of outermost layer from F max is the maximum stress. Y max is outermost layer and F max is maximum stress. From flexural formula, F max equal to M by I equal to Y by Y max. So flexural formula, F max equal to M by I equal to Y max, or M equal to F max into I divided by Y max, that is equal to maximum Z. Z is nothing but the section modulus or modulus of section. Section modulus of various sections. Consider a rectangular section with B and depth D. Moment of inertia about the neutral axis I equal to BD cubed divided by 12. So moment of inertia about the neutral axis I of the rectangular section is BD cubed divided by 12. Section distance of extreme layer from the neutral axis equal to D by 2. Depth divided by 2. Then section modulus Z equal to I divided by Y max, that is BD cubed divided by 12 divided by D by 2. From the definition we got BD cubed divided by 12 divided by D by 2. Finally we got BD square divided by 6. Now consider the circular section modulus. So consider dia D of the circular section. The moment of inertia about the neutral axis I equal to pi into D power 4 divided by 64. Distance of extreme layer from the neutral axis, that is Y max equal to D by 2. Therefore section modulus Z equal to I divided by Y max by D power 4 divided by 64 divided by D by 2, that is by D cubed by 12. So rectangular, consider the section modulus is BD square divided by 6, and circular section by D cubed divided by 32. Now compare the strength and stiffness of the beam. First of all, what is meant by strength? The moment of resistance offered by the beam. The moment of resistance offered by the beam when external forces are acting. Then that is called strength of beam. The moment of resistance equal to F into Z section modulus. The moment of resistance M equal to F into Z. Moment of resistance depends upon the section modulus. Moment of resistance depends upon the section modulus. Therefore, value of Z is greater strong beam. Value of Z is greater than, then the beam will be the strongest one. Beam of I section mostly used in the rails because of when the flanges alone withstand almost all bending stresses. So beam of I section of mostly used for rail section for the withstanding the highest stresses. That's why. So section modulus is very important for considering the strength of the beam. Next, stiffness. The resistance offered by a beam against a deflection from its original straight condition is called stiffness of the beam. The resistance offered by a beam against deflection. So resistance offered by a beam against deflection from its original straight condition, that is called stiffness of the beam. Next, important formulas. Flexural formula, we know F by Y equal to M by I equal to E by R. Here the case F max equal to maximum bending stress equal to Newton per mm square, and the Y max equal to distance of extreme layer from the neutral axis, that is mm, and moment of inertia of the resistance or bending moment equal to Newton mm. I equal to moment of inertia mm power 4, and Young's modulus E equal to Newton per mm square, and R equal to radius of curvature.